All right, we've got our last look at relations here. Our relation R defined on n, so again our Cartesian product would be n cross n, defined in such a way that 2x minus y is going to be equal to 5n, so really what we're saying, 2x minus 5y is a multiple of 5, or we're saying that 2x minus 5 is divisible, 2x minus y is divisible by 5. Now we're trying to determine, is the relation reflexive, symmetric, and or transitive? Of course, if it was all three, we would call it an equivalence relation. So let's look at this. So we've got xrx. That's going to imply 2x minus x, which is equal to x. Well, sometimes when we've got n, x is going to be a multiple of 5, but not always. In fact, generally, it's not going to be a multiple of 5. So this is not reflexive because it's only sometimes true. We would need it to always be true if it was going to be true. All right, x is related to y. So now we're starting with the assumption that this is true. So we've got 2x minus y is going to be equal to 5n. Well, if we think about y being related to x, that would imply 2y minus x. Substituting in here, we could say from this one that y is the same as 2x minus 5n. So we would end up from this one, 2 times 2x minus 5n minus x. That's going to give us 3x minus 10n. This is not a multiple of 5. So we are not symmetric. And now we want to test transitive. So now we're assuming xry is true. And we're assuming yrz is true. So that's going to imply 2y minus z is a different multiple of 5. Now we want to test, is x related to z? Is this true? Well, this is going to imply 2x minus z. Again, we can do the same thing. From this one, we see that z is the same as 2y minus 5m. So 2x minus quantity 2y minus 5m. 2x minus 2y plus 5m. We could say that, again, we know from above, here we had y as 2x minus 5n. All right, so now we've got negative 2x plus 10n plus 5m. This is not a multiple of 5. So we are not transitive either. Also, for any of these, you could give a singular counterexample to show it's not true. Yeah? You could plug in and find an example that is not true. All you need is one counterexample to show it's not true. You don't have to do it the algebraic way. I like the algebraic way, but it's not necessary, not at all. A single counterexample will show it's true. Conversely, to show true, you can't have a single example. I could find a single example here. If x is 5, yeah? 10 minus 5 would be equal to 5. It is true. So to show true, you have to use algebraic methods or other kinds of proof. To show false, one counterexample. To show false is all you need. And I will see you in class.